So 43, more dilations. Okay, more dilations of a triangle. It says all the triangles are dilations of triangle D. That's my starting point. Okay, so this one right here is where we're starting at. They all use P as the center. Notice all the lines are drawn from P, but they have different scale factors. What do triangles A, B, and C have in common? How about E, F, and G? So what does A, B, and C have in common? What do you think? They're all smaller. What's that mean about scale factor? They're not all the same. What's that mean about the scale factor? They're all less than 1. Okay, scale factor of 1 would give you the same triangle as D, less than 1. It's going to be smaller, so the opposite is true for the other ones. So these are obviously all smaller. Scale factor less than 1. Smallest one would be A. This is the exact opposite. These are all, of course, larger. That means the scale factor is greater than 1. Here's our original scale factor would be 1 there. All right, question 2, I'm actually going to have you put a little grid on this side of your paper on page 42 where it's nice and blank there. So put a little, just a little 6x6 quick grid there. You don't have to draw all the lines. But on that blank sheet, quick sketch there. If you want graph paper and want to tape it on, help yourself with graph paper up there. Whatever you prefer. Okay, once you have that, I want you to put those points on there. All right, so here are your directions. The center of dilation is the origin, okay, 0, 0. I would like you to draw that shape, put those points in with a scale factor of 1/3. So I'd like you to adjust all those points from the origin, from 0, 0, with a scale factor of 1/3. having trouble knowing what that means, remember, times a third would be the same as dividing by 3. So if that makes it more helpful for you. All right, every one of those is at 6. So 6 times a third, all of them now should be at 2. So there should be your new point. Again, you can tell where the center was because it doesn't change, right? B did not move. So even looking at the picture, you should be able to tell that. So every one of those is at 2. Make sure you label. A hat, B hat, so on. That's good, thank you. All right. Now we're going to go on to the Are You Ready on top of page 45. Directions are on 44. It says triangle EFG was created by dilating ABC. So here's our original with a scale factor of 2. So this one is twice as big. From center D. Triangle HIJ was also from using A, B, and C. This one has a scale factor of 1/2. Okay, so as I get smaller with the scale factor, it gets closer and closer to the original. The bigger the scale factor, the further it is away to the right. It says, what would the image of triangle ABC look like if the scale factor is 0? So we talked about if it's 1, right? It's the original. 1 would be ABC. How about scale factor of 0? Where do you think that would go? Where? Scale factor of 1, if I'm doing ABC with scale factor of 1, it stays in the same spot. So where does 0 move? Yeah, it is less than 1, so it's got to be left then. Right? It's got to be left of that shape. What's that? It would go to D. Anything times 0 is 0. If your triangle doesn't have any length, it's going to just be a dot. So it would move to point D. Anything times 0 is nothing. So all those points will just be stacked on top of each other. One step further, how about a scale factor of -1? Where do you think that goes? Why? What do you think?
Oh, it's like -1, or it will be like I think it's like possible.
It is possible. It is possible. Claire? To the left of D. Right? To the left of D. So scale factor of 1, 1/2, 0. It's going to just get further to the left. It is going to be the same size. The only difference is, remember, A has got to stay on this line, so A is actually going to be on the bottom now. A prime, B prime, C prime. And it would be the exact same distance away. Okay, -2 would be further left, same size as this one. You could do that as well. So what happens to a shape if it is dilated with the negative scale factor? You kind of already mentioned that. It will be left of the center of dilation. Okay, how else would you describe what happened here? Because A is no longer on top, how could you describe that? Would you say it's flipped over? What do you think, Taylor? How would you describe that? Flipped over good enough for you? That's not good enough? What do you want to say then? Better have something better then. Gabby, what do you think? Flipped over, is that good enough for you? It's good enough for Gabby. Triangle's flipped over. Triangle's flipped over. Good enough for me as well. We'll wait for Taylor to say anything better, otherwise we're going to leave it. All right, page 46 then. Right into the homework, page 46 to 48.